All right. Good evening, fellow students. Without further ado, let's get started. All right. Good evening. Okay, so for today, the aim of the lesson is to finish off the inequality with induction, right? And then start learning on the function, okay? I really hope, guys, that you did the note homework, right? I'm not going to talk about what's the domain of a polynomial, man. I'm not going to talk about that in the class. I really hope that you had written the notes and know what the domain of, for example, a square root of x is, what the domain of a 1 over x is. I really hope that you know it, okay? Without further ado, let's get started. So the aim of the lesson today is to go over the induction with inequality. And I'm probably going to talk about 3 examples. And then function. Especially, I'm intending to talk about the rational function. I want to talk about who? Rational function. Okay. Starting off with the linear over linear, but later on we're going to talk about the quadratic over linear, cubic over quadratic, who knows what. Okay. So fasten your seatbelt for the induction with inequality, because as we pointed out last time, it ain't the easiest one. Because why? Not only should we be able to apply the induction hypothesis, but also there's some involvement that I need to have, right? Okay, so that's why it caused the problem of this, because often when we have induction with inequality, not only applying the induction hypothesis, but also we have to work with some of the identities that we need to derive on our own, right? So then let us have a look at that particular cases, 3 examples with inequality, and we're going to move on to the function. So this was also a very nice question asked in the question folder that I saved it for today. Why? Because not only is it an exam question, but also it's very nice to work with. So just to make it more clear for you guys, I will make it dark for the contrast. Hold on a sec. Right, check this out. So for this term, I really hope that you're able to derive it. I'm not gonna work on this. And what do you think? Can you just sort of tell me? You're gonna multiply by who? Radical conjugate, right? So it's probably better if you multiply top and bottom by his conjugate, root n minus root n plus 1, then you're gonna get that result, okay? So I'm not gonna go over that. I always suppose that you already know it, okay? Know how to do it. So I'm gonna write it for you because of the contrast. Square root of n plus square root of n plus 1, boom, is the same as the difference of such terms. Oh, wow. That's what I have, yo. That is what I have. I'm very happy. And then what we had to prove, yo, is the following. Let's have a look at the number 2. What they say here is show that the square root of 2 minus 1 is less than 1 over 2. Using this identity, so that was number 1. I had to show the number 2. Well, in order to work with number 2, it's probably better which side you want to start with. Would you start with number 1? Left hand side or right hand side? Choosing the side for the inequality is the key for proving, right? Not just induction, but in general cases. So would you like to start from the left hand side or the right hand side? Yes, let's start with the left hand side. You know why? Because I now see that he is merely the form on the him, right? So that's the case when n is equal to who? Just 1, right? It is just 1. I'm very happy. So letting the n equal to 1, I know that the root 2 minus 1 is created here. You know what I'm saying? But they asked me to use it, They asked me to use the identity. So it's probably, in my respect, that I will make this is equal to who? The left-hand side of the identity that I have created, right? So let's plug it in. If I plug it in, what do I get? I'm going to have a 1 over, 1 is also square root of 1. Don't forget that. It's going to be square root of 1 plus square root of 2. You feel me? That's what I have. But that's equality, right? What you have to derive was inequality. Can you derive this direction of inequality based on the identity that I've just put? I think so. Why? Because if you remember the thing about the fraction, bigger the denominator, the smaller the fraction, right? If you compare with him and him, who has a bigger denominator? The purple one does. So the blue one is obviously going to be bigger, simply it has a smaller denominator. And that proves the inequality, you see? Okay, so we are ready. We are ready to attempt the induction problem with inequality of the question above. So what the question said was the following. Prove by mathematical induction for the following. So what they asked me to do is that I have a series r is equal to 1, r going up to n, but 1 over square root of r yo is bigger than square root of 1 fourth. Gotta be careful. And bigger than equal to 2. You see? Look. N bigger than equal to 2. That means your first term is gonna be when n is equal to who? Thank you. The first term, bro, is going to be when n is equal to 2. Okay, so let's try with the basic step, right? Let's try with the basic step when n is equal to 2. So if I start from the left-hand side, right? If I start from the left-hand side, it is a sigma. We learned in great details about sigma, right? If I'm adding from first to the second, that means I'm adding the first two terms, right? So when r is equal to 1, that will be just merely what? 1. And 2 is 1 over root 2, right? And I gotta show that this is actually bigger than square root of 2, right? But you know what? Previously, you showed this inequality. Previously, you proved this inequality in the first two parts, yes? And from him, can I derive that? From this point, can I derive that? Yes, why not? Why? Because I just have to rearrange the one, right? The blue one is you already proved in the second part. So this is true, right? So the result that I have to prove for the basic step is true because of the identity that you proved previously. I'm happy. I'm very happy. Now that's the first step in it for my induction. So what's the second step that I have to do? Induction hypothesis implies who? The result to prove. I now want to talk about the induction hypothesis implies the result to prove. Right? Let's do that. So here, my induction hypothesis is given by him. And I'm going to send him to where? So let's assume for what? N equal to k true implies n equal to k plus 1 true. Right? Suppose that. So who's going to be your induction hypothesis? Replacing n equal to k. Replacing n equal to k. Good. Right? Very good. But also, do not forget to write down the result to prove, because induction is always nice to have the answer. Right? It's always nice to have the answer. So what I'm going to go here is from this, I'm going to merely change the k with k plus 1. That's my RTP. Righto? So that is the result to prove. And for the inequality with induction, result to prove might be essential that you choose your side. Would you like to start from the left or right? Is the key of solving the induction with inequality. In this case, which one would you like to start with? Would you start with the left or right? It's probably better if you start with who? The left. Why? Messier the better. I mean, look, I have it from 1 to k plus 1 many terms to substitute in it. It's a lot easier, a lot better for us in this sense that I start from the left. Always messy part. Okay.